Hi viewers, welcome to NCKHUB Consulting and Training. As part of our Golang playlist, in this video, we will be discussing on the operators that are available in Golang and how are they classified into, what are those operators, what kind of operations can we do as part of our Golang programming language. So before going deeper into the Golang operators, to have a high level understanding on the operators. So operators are very much basic fundamentals for every programming language because they allow us to perform certain operations as per our requirements. Okay, and depends on the programming language. These operations have certain limitations. Like certain programming language will help us or will allow us to do certain operations where certain programming languages will not provide an option to do certain things. So, considering that aspect, we need to understand what are the types of operators that are available in Golang and what is the classification that we have. So as you see on the screen, we have altogether seven operators or all the operations that are available in Golang are classified into seven categories. So here we start with arithmetic operations and then we follow by the same order that we have here, relational operations, logical, assignment, bitwise, increment, decrement, as well as some miscellaneous operations. So I don't have much theoretical concept here. Instead, what we do is we'll dive into the code where I have examples for each and every operator's classification, and I'll walk you through the code. That way, it will be easy for your understanding. So the very first thing that we have here is arithmetic operations. So arithmetic operations, basically in this particular classification, we have five different types, which is addition, subtraction, multiplication, division, and modulus. So what I have done here is it's a simple basic Go program which have a main method, and I did not use any other packages apart from this the actual package which have the import and the possibility of printing the statements to the console. Okay, the package name is FMT package. So I can say it as library as well in, to have a better understanding. Okay, so I have taken two variables here and I tried to use a short variable declaration and I tried to declare and initialize two variables in the same single line using short variable declaration syntax, and I tried to perform five different operations which are arithmetic operations on those two variables. Now what I do is I'll just try to execute this program, let it compile and then give us the final response. So if you see the output here on the console, for addition we have 10 plus 8 and for subtraction we have 10 minus 8 and multiplication we have 10 into 8 and the division and then modulus. Okay, division will give us the quotient and modulus will give us the remainder. So that's how we got. This is how we can perform the arithmetic operations, which are simple and very basic level operations that we have in Golang. And the number of operations that I have under arithmetic operations classification is five operations. Hope we are clear on arithmetic operations. The next one we have in the list is the relational operations. So let us go to the example of relational operations. So how many relational operations are there as part of this Golang classification? We have altogether six relational operations. What are they? So equal to, not equal to, and greater than, greater than or equal to, and less than or equal to. So equal to in Golang we will use only double equal to. There are certain programming languages we use three equal to's, and there are certain programming languages which use double equal to. And Golang is one among that where we have equal to as the double equal to. Okay, so not equal to is pretty much the same exclamation mark followed by the equal to symbol, greater than, less than, greater than equal to, and less than or equal to. So again, I have followed the short variable declaration and I tried to declare multiple variables in a single line. And once this declaration is done, I try to perform the operations on all these parameters, the variables whatever we declared, and for all the first five operations I have used a and b variables, and for the last operation I have used a and c. So the output, the result of these relational operations will be a Boolean value. So let me try to execute this program. You will understand it very clearly. So equal to is false because 10, a value is 12 and b value is 10. Then equal to 12 is false. So that's where we got false for the equal to, and not equal to. Yes, a is not equal to b. That's where we got the true. And greater than, for which we got a true. Less than, we got false. The similar way for the other two. So basically, the output of the relational operators is a Boolean value. Whereas for the arithmetic operations, we were able to get the integer as the output. Okay, so this is how we can deal with the relational operations in Golang. So how many operations are there as part of the Golang classification in relational operators? We have altogether six types: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. And this is how we can do certain operations for relational operations in Golang. And the output of relational operators is Boolean value. Hope we are clear on the relational operators. Now let us go for the next one in the list, which is logical operator. So let us open the example of logical operators. So basically, logical operators are three types. What are these? And, or, and equal operator. So these are, so basically, equal operator is followed by a exclamation mark. So this is what we need to focus here. Okay. And here we need to focus on this. And here we need to focus on this. So these are the three logical operators that we have. Okay, so I have taken two variables using short variable declaration, initialized those two variables with two values, and then I try to perform AND operation, OR operation, and NOT operation. So basically, P and Q values are 10 and 8 respectively, 10 not equal to 8. In case of AND, 10 not equal, basically I have used a if condition, which is a decision making statement. We will discuss on the possible types of if conditions that are available in Golang in a separate video. But as of now, I can say like I have used a simple if statements to give a demonstration on logical operators. So more on if statements, how many possible if statements are there, what are they, how can we do that, all those things we will deep dive in a separate video. Okay. Okay, now coming back to this, so what I tried to do here is, so for AND condition, I have put two things, P not equal to Q and P less than or equal to Q. So to a general understanding, P not equal to Q is true, P less than or equal to Q is false because 10 less than or equal to 8 is false. Okay, so that's how we have here one true and one false. Okay, so from our understanding, for AND, it should be both true, then only it will give us a true. Okay. Now, or P not equal to Q or P less than or equal to. So, or means either of us has to be true. Okay. And the last one we have is not. We have given the condition P equal to true. Just now we completed in relational operators equal to will compare whether both the values are equal. But before that we have a not there. That means it should not be equal. Then this condition will be satisfied. Let us try to execute this program now. So if you see here, and operator related statement doesn't even print here because this condition was not satisfied. Because for an and to be satisfied, both the conditions have to be true. Then only it will go inside the if statement. Otherwise, it will not go inside the if statement because condition was not met. But for the other two, since the condition was met, it was able to go inside this block and it was able to print the output statements to the console. That's where we got the statements for OR operator and equal operator. Basically, it's not equal. Here, the example will be for not. So this is a logical operator here. Equal is a relational operator. It is not a logical operator. Okay. So hope we are clear on the logical operators. So what are the next operators that we have? Assignment operators. So let us go to the example of assignment operators. So basically, how do we assign a value? Okay, so this is a simple assignment which we do assign the values using simple or single equal to. So double equal to will be a condition that we check for equal to between two variables. But if you use a single equal to, it means that we are assigning a value of one variable to another variable. So a simple assignment is done using a equal to, single equal to. So when you use a single equal to in Golang, that means that you are assigning value of one variable or one expression, output of an expression to a single variable. That indicates using a simple assignment, which is done using single equal to. Okay. So apart from this simple assignment, we have multiple other assignments, which are the combinations of arithmetic operations along with the equal to. So how many arithmetic operations are there when we were discussing? Five arithmetic operations: addition, subtraction, multiplication, division, and modulus. So for all five, we have assignment operators: add assignment, subtract assignment, multiply assignment, division assignment, and modulus assignment. So this is how we can perform the assignment operations in Golang. Let me try to execute this program. So if you see here, the two variables which I have taken, and I try to print those two variables before doing any kind of operations. So the actual values which I have taken is 45 as P and 50 as Q value. And the simple assignment, I assigned Q to the P, so it was overridden there. And from there on, for all the other operations, sorry, for the other assignments that I have done, the value of P has been changed on a codes, and these are the stages where the value of b has changed, and this is the final output. Okay, so this is how we can perform the assignment operation. So as a whole, how many assignment operations are there? We have six assignment operations, out of which one is simple assignment and other five are the combination of arithmetic operations along with the equal to statement. Okay. So the equal to symbol. This is how we can perform the assignment operations. Hope we are clear on the assignment operations part. Now the next concept we have is the bitwise operations. So basically these bitwise operations will handle the values in bits format. Even though you assign or you initialize the variables with the numbers, with actual integer values, internally that Go compiler will consider them as a consider their equivalent bit values. For example, for 5, the bit value of 5 is 101. So if you start up doing the operations using the bitwise operator, so Go compiler will default take the bit values of those integers which you are trying to use as part of your program. So when you say A and B here, even though you assign the values to both A and B as 5 and 3, since you are applying a bitwise operator there, so the Go compiler will take 5 as 101 and um, 3 as 011. So this is how the bitwise operator will take, and it will give A and B. It will perform the operation on those bits, and it will give the final statement. Similar way, A or B also will be done on the bitwise operator. It's not on the actual operator. And followed by the bitwise XOR, bitwise and not. All these things will follow the same context. Maybe I'll try to execute this program and we will relate from the output to the operation. That will be a easier one, because bitwise we cannot do a normal calculation like how we do for normal values. Okay. So for bitwise AND operator, so 101011. So for all the three, if you see, the extreme right side one is the common thing. That's where we got only one here. So bitwise operator of 1 is actual value is also 1, and that's where we got 1. And similarly for bitwise OR, so 101011. So for all, since it is OR, it will be all 1 for the output. So if it is all 1, that means that 7. Value is 7. That's where we got 7. Similarly, for XOR, we got 6. For AND NOT, we got 4. And left shift and right shift also, we got it. Okay. So this is how we can make the bitwise operations. But with bitwise operations in general day-to-day programming, it's a little low of use. Only in a scenarios where there is a critical demand or you definitely have to be using bitwise operators only, you will be using this. Otherwise, these are not much used in our regular programming. I mean, at least for my awareness, I haven't used it so far. And the next operations we have here is increment and decrement operator. So increment, decrement operator. This is a simple example. I have taken two variables P and Q and initialized those two variables with the two values 10 and 12 respectively. And I try to print the initial value of P and I try to increment P and decrement Q. Okay. So let us see the values of P and Q after increment and decrement. The value of B after increment is 11. Value of Q after decrement is 11. So Q minus minus means 10, 12 minus minus. So it will reduce 1 from 12 and it will increment 1 to the 10. So totally after increment, the value of B is 11 and after decrement, the value of Q is 11. This is how we can do increment and decrement. And if at all you can assign these values to another variable as well, that is something which you can give, you guys can give a try. But I did not give it, but I can just tell you that this value, the output of this value can be assigned to a variable such way of like this. Okay, so it's not exactly the same way, but there is a possibility that you can do this. Okay, you guys can just give a try on this. And the last one we have is miscellaneous, which is nothing but related to the pointers. So Golang has a separate concept called pointers, which we might have seen in C language, provided if you guys are familiar on it. But if you are not familiar, it's pointers, which is a new thing which we have in Golang, which was not part of other programming languages like Java. And there was some introduction video which was covered, which has this detailed explanation on pointers. Sorry, high level explanation on pointers. You can refer to my old videos on Golang. But if possible, we'll cover a separate topic for pointers. But as of now, pointers is a variable that will store the reference of the actual variable. But the actual value will not be there in that variable. But this pointer variable will store the reference of the actual variable. For example, take this program, whatever we have. So in this program, I have declared A and B. So A is having a value and I initialized with the value 42. But if you see the B, I am not assigning a value directly to the B. Instead, I am assigning a value called ampersand A. Ampersand A means I am asking the Go compiler to get the address of A or reference of A and then store in B so that I am asking the Go compiler that B should hold the reference of A. It should not have any actual values. Okay. So now how do I access the value, the original value by using B? Okay. First of all, if I use directly B, I will not get the actual value. I will get only the reference of the address, reference address of the A variable because I have stored reference address of A variable in B. So if I directly point B here, I will get only the reference address of A. I will not get the actual value. If I have to get the actual value, what I need to do is I need to use another symbol called star here. So this star will enable the compiler to get the actual value which was stored in the address which B variable have. So B is holding the address of A. So what is the actual value of A? That will be printed in line number 11. Let me execute this program. I think you are clear now. So here the address of variable is this is the address which we will not be understanding it clearly, but yeah, this is how the address will be there. But what is the value that is stored in the address? So this is the value. Okay, so this is the address of A which is stored in B, and this is the value of A which we can refer using a symbol star. I think that's all we have for this video, and thanks for watching.